Yep.
Okay, very good. Aaron Burt, you're on.
So I've finished. I've finished now.
Thank you, Neil.
Yeah. So that was great, Neil. It's a tough act to get somebody from overseas. I've been part of 2 or 3 conferences in the last couple of months that have had issues a lot worse than that, trying to get somebody connected from not just across a small pond, but across a very, very large one. So excited to be able to have you on here, Neil, and sorry about the lag here. So we're going to take just a quick couple of minutes to set up a bit of a panel discussion. Obviously, we're winding down to the end of this, so this is really meant to be a bit of a relaxed conversation. So what we'd like you guys to do is, if you have any questions, and we'll try to go through some of them that weren't answered during the presentations, but if you have any additional questions, pop them into Q&A now. We're going to have Dr. Victor Champagne, Dr. Tamidin, and Aaron Nardi on here to just answer any of the questions that you might have with regards to cold spray, anything at CSAT or otherwise. So we're gonna enable the webcams for our folks who are on the panel, and I'll kind of lob your questions back and forth here. But if you throw them into Q&A, we'll get them answered. We'll take maybe 15 or so minutes here. As long as there's interest, we'll keep going. This is the last part of the afternoon, so a miracle of all miracles, we've stayed on schedule at CSAT, so thank you to everybody for being a part of that, and especially our presenters for staying on time. So this will kind of conclude the afternoon, but we do want you to stay tuned for the final wrap up and any announcements from Vic once the panel discussion is over.
So Aaron, should we have a sidebar or just talk like this to everybody?
So if we want to go ahead and share our videos here, Vic, we can have our conversation here. Aaron Nardi, I'm not sure if you're on, and you can enable yours as well. And then just any questions as they roll in, we can start passing around. One thing that's popped up is just looking at everything that's going on in the defense space and commercially. What do you see as the biggest differences in transition between the defense sector and the commercial sector?
Aaron, you want to take that, or you want me to start? Right. So, all right.
Yeah. So why don't you start?
I'm hesitating because I want to be kind, and you know, I don't think there's one size that fits all. I mean, someone had a slide, you know, indicating as such, and there are unique challenges, you know, for both sectors. Typically, I'll say on the industry side, a little bit more agile. Things happen quicker just because the infrastructure is smaller. However, that's not always the case. With large OEMs, we've seen delays of over a year in getting systems installed. And I think one of the challenges, and it really shouldn't be a challenge, but it is, and we're addressing it, or it's being addressed, is to have a standardized document for booth qualification. I think that's going to help tremendously on both the commercial side and within the defense industry. Having a set of criteria, having test data in the form of just hazardous analysis or whatever environmental concerns need to be addressed all in one document so that the environmental and safety folks can view that document and have a warm fuzzy instead of setting up a lot of roadblocks. And there are numerous roadblocks that have been set up with getting systems up and running, whether it's in the Department of Defense or whether it's in industry, because people just don't understand the differences in the process. And what gets me is, so I've got 36 years. Prior to this, I was in thermal spray, powder coatings, solvent-based aqueous coatings. Never had the same problems setting up even an HVOF system that has a hydrogen tank and flame coming out, and you're pouring powder into that. But yet we've got cold spray in which we don't have any combustion fuels or anything, and all sorts of red flags are coming up because they don't understand cold spray. And there's dozens and dozens of thermal spray spooks that have been qualified and set up worldwide. So that's my 2 cents on that. Aaron?
Yeah, so I guess, let's jump to another question. Got a bunch.
Yeah, I meant Aaron Nardi. Yeah.
So have there been any, I know you meant him. Has there been any research into, so that anti-fouling, I would imagine on the Navy side, water, underwater fouling of surfaces. I guess I would say, your copper solutions, right? But they're not going to be great from a corrosion standpoint. So I don't know that we have a lot of data on anti-fouling in that sense. Obviously, we generate a ton of data on fouling of nozzles.
Right. No, anti-fouling. So when I first started, the Navy was still using the anti-fouling components as the Army was too, on the copper sulfates and such on canvases, for the Army and tents, and on ships, right, to mitigate the barnacles and stuff attaching and reducing efficiency of ships. But then those were more or less banned in the, I'll say the mid to latter 1980s. But the Navy is still using, anti-fouling copper-containing, coatings, but we have not investigated them for cold spray, primarily for the reason that Aaron Nardi just indicated. I mean, you can't be slapping on, bare copper on a steel ship. You'd be creating a really good battery. And so you need some insulative properties on there so that you don't get a galvanic reaction. So from a cold spray perspective, anti-fouling on large structures like that, no.
Okay. And there's a couple other questions here around NDE. And what are our thoughts on what NDE techniques are needed as we move towards structural repair, and how do we get everybody on the same page?
Sure. So I'll start off, and then Aaron and Nardi, you can pitch. So again, if you take a look at one of my slides, I showed the vision, right? The vision which advanced from phase 1, cosmetic non-structural repairs, to phase 2, which are structural repairs, and then ultimately near net shaped additive manufactured parts. And with each phase becomes a level of scrutiny in terms of the integrity of the deposit, of the structure, of the near net shaped part, right? And so a cosmetic non-structural repair, you're not testing for fatigue, and so the criteria is not very stringent. So as we advance, what is needed are NDT techniques, all right? Fine. And so we can use and incorporate traditional NDT techniques such as CT, all right, which is used extensively right now throughout the additive manufactured industry. We can use X-ray analysis. It depends on what you're looking for and what the requirements are. I mean, UT is ultimately, very good at detecting delaminated, bonds of cold spray deposits. And so, for the most part, you can use traditional methods. Now, what we try to do is kind of advance that thinking, and we have, and Aaron Nardi can go into, a level of detail, but non-destructive means of trying to not only interrogate the bond, like you heard today, the laser method, but also, simple things like the MMT technique, the scratch test, where we're able to do a simple, benign scratch, not very deep, and from that get our yield and even some, toughness sorts of data. Testing the integrity of the powder going in, making sure that you've got, in situ sensors, transducers, means of process control is going to be extremely important as well. So there are some advances, advances, but yeah, I mean that's an area that's open now. Trying to find, you make a near net shaped part. How do you know that it has the yield, the ultimate tensile strength? So yeah, that's a challenge. Aaron Nardi.
So yeah, so let me jump in. So as far as the application space here, I think there's a lot of opportunity in I think we have a few a few areas, a few things we already know about evaluating bond lines, but evaluating the deposit itself, the biggest challenge I see is most of the techniques we have, the CT scans, the various other techniques for evaluating porosity and things like that in a deposit, by and far that's not what's driving problems in structural applications. As we get to structural aluminum, we're talking about extremely dense materials. We've already densified them before they've even gotten to the structural, before we even switch over to helium. We can densify a deposit so that we don't have porosity. The problem is those interparticle defects, and having techniques that can really discern the difference between a well-bonded structure, a cohesive structure that can actually carry some strain and some plastic strain, and something that doesn't, is I think where the most difficult area is. And the other thing is we definitely need the post-process NDT as well as the in situ, I think. Those are both going to be important aspects to this. I think from a machine learning standpoint, all that, the in situ is going to be beautiful because we can actually see layer by layer what we're depositing, and we can hopefully predict where problem areas might be, for instance. But we still might need that after detection, because if something happened to a lower layer in the structure by adding a top layer on with a bunch of residual stress in it, we're going to need to be able to find that, again, going back to the bond line or close to the bond line. So if that's what I would.
So let me say one thing. I see Tim Eden, even though I don't see his smiling face, I think he's on, so I don't want to leave him out of this panel discussion because it was our intent to have him on. So, Tim, if you can hear us and respond, we will include you in these in discussions, and Aaron Nardi and myself will cut our responses in half. Tim, are you there?
Yeah, can you hear me?
All right, barely. You're like yep. Neil Matthews. So, are you in Australia too?
I guess. Because I can't. I'll try to. I guess you can't hear me.
Yeah, you're faint.
Yeah, we can hear you. We can hear you.
Yeah.
Go ahead.
Yeah.
All right. Okay. Okay, yeah, so I'm on. One of the things we're dealing with here is we're trying to take some cold spray and measure bulk properties with ultrasound to see if we can then relate back, the bulk properties to, stiffness or elastic properties that you would need to do your structural analysis with. And we've just started that, and we're waiting to get back the results on that. We've also been doing things with eddy current, and there's some things that you can definitely see with eddy current as far as some of the bond line and the deposition issues, and also it takes some signal processing to pull the information out. So I think we're starting to get there with being able to get property data out of NDE techniques.
Okay.
Excellent. So there's a lot of questions coming in about the copper and its place with cold spray in the current pandemic climate. So your general thoughts on the applicability to cold spray copper in the age of
all right. So I'll start because I did a lot of the pioneering work in this area, and also in general in regards to working with the Copper Development Association, ATI, University of South Carolina Medical Center, Sloan Kettering Cancer Institute, way back when they were qualifying and registering hundreds of copper and copper-containing alloys, for its antimicrobial properties. So number one, it's well established. There's numerous, dozens and dozens of good research papers from medical doctors. Dr. Harold Michaels, for instance, we had worked with at the time. He headed up the CBA. I'm not so sure he does now. But he's a medical doctor, and so we had teamed up under some large programs, and so I was the materials guy, he was the medical guy, and together, it's like the Reese's peanut butter cup. Now, cold spray copper, if we take a look at the pie, is a slice of that pie in terms of when you enter an area in which you need antimicrobial protection. And when I say area, what does he mean by area? It could be a hospital, it could be a medical shelter, it could be a sports stadium, it could be a transit, it could be a subway system. Wherever you have people and you have touch surfaces, there's a need for antimicrobial protection, right? And so each one of those is going to pose, it's like, developing an application, right? And just picking the right tools, the right nozzle, the right materials, depends what the substrate is, et cetera, et cetera, et cetera. So there are, even myself right now, okay, I'm reaching over and, this is my COVID mask, right? You know what this is? I bought the best money can buy. This is a copper infused mask that I can wash and reuse. And so I spent like 20 bucks on that, but I can reuse it. And the good thing about it is that if a virus, bacteria, even fungus, it's even been shown to kill spores. So within a couple of hours, those little bugs are dead. And so again, where does cold spray fit into this? Well, if there are paints out there, there's fabric out there, there's copper-containing alloys that you can make light switches or any, even and there's copper-infiltrated polymers for mouse pads. So it depends on what it is and what your application is. So if you need some wear and you got a metallic surface that's interior, yeah, then I probably use cold spray. If I've got an exterior application and I want to coat an aluminum stadium with copper via the cold spray process, good luck, because what are you going to do? You're going to create a battery. And so that makes no sense whatsoever. And so we had done some interior sections of hospitals, you know, over bed tables, good applications. So it's you know, I'm going to cut myself short. It's dictated by the applications, but I believe, you know, there's paints out there right now that, you know, so if I go into a church, it's all wooden pews. I mean, there's virtually no cold spray applications. I'd be painting those pews. So that's all I'm going to say.
Yeah. So if we switch gears, unless Aaron already...
Well, the other thing I was going to add is, you know, the applications where I see copper potentially being a benefit by cold spray is if I have something that I can't change the substrate out. I can't swap it out for a copper alloy. I have to actually change the surface of it, and that surface needs to be more durable. So I'm thinking of like higher strength components, things that have to be like a hard steel or something like that. If we can put copper in, you know, in a portion of that to give us the antimicrobial just in that area, that would be where I'd see benefit for cold spray. But like Vic said, spraying very large areas and spraying commodity materials, especially if you don't need the durability, paints and changing the alloys are going to be a lot easier.
Yeah. So if we switch gears and talk about, you know, we talked about cold spray structural, but if we talk about cold spray for additive, what do you think are some of the big limitations for cold spray additive from a material perspective? And do you think that, you know, to have effective additive components that meet strength requirements, that we're going to have to go through different post-processing, heat treatment or otherwise?
So I'll start this, I guess. Generally, the benefit of an additive part is that you can do a heat treatment. So most of the work we've done with additively produced parts involves some sort of a heat treatment, whether it be a HIP or just a argon treatment. There are probably some reasons why you may not want to do a heat treatment, and we have made at least one part where we just sprayed the material, machined it, and used it as is, and that's the one that that Vic and, you know, we always show for the Patriot missile. So that's as sprayed, no need, you know, but we were able to get the mechanical properties in that as sprayed condition. A lot of materials, when we're going to the harder materials, steels and nickels and things like that, you may need to go through a heat treat to get the kind of properties you want for an additive part. So, but again, additive manufacturing allows you that opportunity. We're really more in a bind with repair, with structural repair, because now you're putting material onto an existing part. You can't just throw that thing in a furnace. So, I'll leave it there. Tim, Vic?
Yeah.
Tim, you got anything? I've been dominating the conversation.
No, I think the with the additive, with the cold spray compared to some of the other techniques, I think that, you know, being able to put down more material, I think that's one of the areas where additive is heading, is higher deposition rate. So I think with proper material selection, proper design, there's a lot of things that cold spray can be exploited for. But I do agree that, you know, to get those properties, like, you know, in an additive manufacturing part, that you have to include post-processing to get there. Over.
Great, great. So to kind of jump back to structural for a minute, if we can show structural as being viable in a variety of different material systems, do we think that it's going to become competitive with the other technologies that are out there for both
Hello.
structural
There
and
doesn't appear to be
non-structural
any activity in this meeting. If you would like to stay on the line until others join, please press 1. If not,
Press 1.
I'll end the meeting.
He's getting annoying.
You're supposed to jump up and down?
So
What's
does that
the
fit?
activity thing?
All right, all right.
I'm not.
Maybe it's
So,
maybe it's the
all right,
brainwaves of the panel that.
Go ahead, Tim, if you want to start.
Go ahead, Doug.
Yeah, so in regards to being competitive
Yeah,
to other AM.
It depends. I mean,
Yeah, well, I
A bit of a
started, but
lag.
I heard Tim, so I shut up. Okay, well, I'll try it again. So, in regards to cold spray competing with other AM technologies like, laser powder bed, E-beam, so it's going to come down to material. It's going to come down to material. I mean, I'll tell you right now, with a few of our aluminum alloys, that we go head to toe with anything in regards to deposition rates, integrity of the deposits, and as Aaron indicated, with a couple of the aluminum, like that 2024 part, we didn't do any post-processing. I remember the properties of the 2024 aluminum were around, 60 KSI and ultimate tensile strength, and I think close to, 9-10% elongation, where a piece of wrought 2024 was, I think, 12 to 15% elongation. Strength level was about the same. And we could live with a slight reduction in elongation values, and there was no need to post-process. So with the aluminums, I think we've got a shot. And certainly, again, if we're talking, if you go way, way back, right, sputter targets, right, sputter targets made out of tantalum, niobium. I'll give, PVD or CVD a run for the money, as long as you can live with the, you're not going to be 100% pure with the tantalum. So, very, very, again, dictated by the application.
Yeah. Do you have anything else, Aaron or Tim, that you want to add there?
Tim, go ahead. No. Nothing?
Yeah, it's like, the great depends work on, it's the material, the application. And so I think if anytime you can get, take advantage of the deposition rate of cold spray, then I think you've got a shot if you can meet, you can meet those material properties. Over.
Dr. Nardi.
Yeah, so realistically, I think you said it all for the additive side. I guess I'll just jump in a little bit on structural repair. I think that was kind of implicated there as well. When we do get to structural repair without doing, extra processing to the materials, we're in a very good shape with aluminum. Aluminums, we can get the kind of properties we need, the high ductility and everything else. With some of the higher density materials, the steels and so forth, I still think we have room to grow. I still think, we need to push the boundaries on those materials a bit. And I'm not sure if that's going to come from higher temperatures, higher pressures, or a combination of the two. But we do have to, push the envelope a little bit with some of the steels to get to the high performance mechanicals that we need there for structural repair.
Yeah, I mean, one last thing I'll say in regards to that, it's like anything else, right? What was paying the bill for, 10 or 15 years, right? I mean, was the development of aluminum. So the more money you throw at it, the more resources you throw at it, the more advanced you're going to be. I mean, simple as that. If we had concentrated on stainless steel or titanium or, some of the other alloys,
If your audio got disconnected,
Yep,
just
that's what I
rejoin it real
did.
quick.
That's what I
Yep.
did.
I think I'm back too.
Yep. So do we have anything else?
So we're running close to
Yep.
6 o'clock here, and the sun's shining on my face, which must be the sign that it's time
That
to
sounds
start
good.
wrapping up here. Just one last question for each
All
of
right.
you to take, and then we can close out. What's one thing in less than 60 seconds that you are really excited about for Cold Spray in 2020?
What's the music?
Nardi, you go first.
So I would say I'm very interested in alternate methods of accelerating powders. So I think we're doing a lot to try to advance that, try to get away from helium where we can. And so that's really an area I'm excited to do in the next year to two.
Okay, now my 30-second snippet on that is basically taking what we've learned and transitioning it even more than what we are right now. And just in terms of establishing more of an industrial base, I think there's
Mute off.
there she is again. You know, she's really annoying. No, I think there's numerous dozens and dozens and dozens of applications, untapped gold mines out there that are just waiting to be discovered in terms of applications development and turning a profit. I mean, there's so many, especially with the advent of the wear resistant coatings, with the aluminums that we have, and we're not even I think scratching the surface. And so we need a couple of good industrial partners out there that are willing to toe the line right now and take take the data, take what we've developed and boom, implement it, transition it.
Yeah, great. Tim, did you have something?
Yeah, this year I see a great rollout in the Navy. We have 2 Navy yards with cold spray systems. We have another one that's going to get it. They're all working together, moving forward. We've got a lot of applications, a lot of interest generated in the shipyards, especially, and I see a big wave of transition and development, and much greater application coming this year. And it'll go to other Navy facilities around the world. So I think that's what I see the most that's going to be happening this year in cold spray.
Yep, very good.
Excellent. So I think with that, we can kind of start wrapping up here. We're 5 till 6. We still have 200 people on the line who are willing to listen to us, but I think it's time for all of us to go enjoy our evenings and grab some dinner. But I do just want to say a couple of quick words and then turn it over, Vic, to you for wrap up. Just a really big shout out to the Solvis team, Annette, Autumn, Caitlin, and Calvin, who have been behind the scenes answering your questions, your technical difficulties. We appreciate you bearing with us during some of the difficulties here. It's really, really hard to get folks from around the world, and especially DoD and non-DoD personnel together on one conference line. So that's why we went with the system we did. We appreciate you bearing with us whenever it was hard, but I think for the most part, we had over 600 people here listening to Cold Spray Talks. That's very, very exciting for the industry. So from the CSAT side, the action team here, thank you for being part of CSAT 2020. We really look forward to seeing you in 2021, hopefully in person at facilities here in Worcester. And so with that, I'll turn it over to Vic to close things out for us.
I'm basically going to end with kind of what I started with, is thanking everybody for their participation. It's unbelievable turnout. I'm very happy about that. I hope we kind of satisfied everyone's expectations. It's difficult to do with a truncated schedule. We tried to do our best at mixing it up in terms of programmatic, roadmap sort of things, big picture, and then down into the weeds a little bit with technical discussions, and then applications and transition. We do have a date set up for next year at Worcester Polytechnic Institute in Massachusetts. of June 22nd and 23rd. Like I said, God willing. And I guess the last thing I'll do is, if you check out my hair here, you know, I need a good hairdresser. And so with this COVID, I haven't ventured out. But again, appreciate everyone's participation, great turnout, and look forward to seeing you all next year. And with that, I wish you good evening, good morning, good afternoon, wherever you are.
All right.
Excellent. Thanks, everybody. We're going to close the meeting down now. Appreciate it, and we'll see you all in
Thanks, guys. Good job.
Thank you. Great job.